Good morning, Algebra 3 students. I'm ready right now to go over everything you ever wanted to know about rational exponents, just as a way of review for you. So just get ready, and we'll try to move through this relatively quickly because it is a review, but I also want to touch on all the concepts. All right, so you have to remember what a rational or fraction exponent is, and the denominator of the fraction exponent becomes the index of the radical. So you can always rewrite in radical form in order to be able to solve these things. So for example, if we have all of these that we're going to take a look at, we do step by step. Remember, this becomes the index of the radical, so the third root of 64. Third root of 64, 4 times 4 times 4, so is 4. 100 to the 1/2 power. A 2, when you put the 2 in as the index, it becomes a square root. Remember, it's the implied 2 that's the index here, so square root of 110. This one and this one look the same, but they're really different. This positioning of this negative sign is super important. This one says that you have the negative of the fourth root of 256. Okay, so it would end up being negative 4, because 4 times 4 times 4 times 4 gives you 256. This one is different entirely because the negative is actually under the fourth root symbol. Now the problem is that I'm trying to take an even root of a negative, and when you take an even root of a negative, you can't do that because anything times itself 4 times, the negatives would disappear, so you don't have a real answer, so there's no real solution to that. So do take note of the difference between these two. This one, you can take a fifth root, you can take an odd root of a negative, and this one is negative 2 because negative 2 times itself all the way, 5 of them will give you negative 32. Just to remind you of those things. If we have a numerator of the fraction also, the numerator is the exponent and the denominator is the index. Okay, so just reminding you of that one other thing that we went over slower in Algebra 2, but important for you guys to remember. So root power. Usually when you're evaluating, it's easier to take the root first and then the power. So let's take a look at these as they get solved down. So we've got the square root of 36 cubed. Root power. Square root of 36 is 6. 6 times 6 times 6 is 216. That could be done out fairly simply with or without any calculator if you take the time to multiply that out. Cube root of 125 to the second power. Cube root of 125 is 5. 5 squared, 125. This negative, remember the negative on this case is out there by itself. It is not attached, so you're doing the square root of 4 to the fifth, which is negative 32. This one, cube root of negative 127 squared. So the negative 127 gets a negative 3, and you square that and you get a positive 9. All right, now this one, you can kind of see, you could have squared it first and then taken the cube root, but that's just a lot more work and it's much simpler this way. This one, you're taking the square root of negative 100 and then cubing it, but square root of a negative 100 is a no-no, so there's no real solutions. You can't get a square root of a negative and stay in the real number system for that. Okay, so hopefully all these things are ringing a bell. If not, then just play me slower and so that you can hear it and really let it sink in. All right, negative exponents. All these rules are the same whether you've got fractions or whether you've got whole number exponents. So a negative exponent actually deals in reciprocals. Okay, so the reciprocal of a to the negative m over n is 1 over a to the m over n. A reciprocal, though, when you have an entire fraction here, it really just completely flips the fraction over, so that makes it just a little bit easier. But let's work through the solutions here. Okay, so the first thing that you would do is take 1 over 16 to the 3/4 power. So then to do this by hand, you would take the index and the exponent and apply those. So the 4th root of 16 is 2. 2 cubed is 8, and you get 1/8. Okay, again, 1 over that number. Then apply exponent index. Square root of 25 is 5 to the 3rd power is 125. This one, yes, you could technically, if you want to, do 1 over 8/27, but usually when people do that, they make mistakes and get confused. The reciprocal just means flip it over. Like when you take 16, you're really taking 16 over 1 and flipping it over. This one is just flip over the fraction, 27 over 8 to the 2/3 power. You're not flipping over the exponent, though. Remember, the exponents mean something completely different. All right, so then you're taking the cube root of each one of these and squaring it. Okay, the cube root of each one and squaring it. 3 squared is 9. 2 squared is 4. So 9/4. So you don't have to make it into a mixed number. As a matter of fact, it's better off as being an improper fraction. Okay. And it is important to be able to go from one to the other. It's important to be able to take a fraction exponent and make it into its radical form. And it's important to be able to take a radical and make it into its exponential form. These things can help you simplify. They can help you solve. It depends on what your purpose is. But let's go through changing these to the other. Okay, so this one, obviously square root. We just did a whole bunch of these. 4th root to the 3rd power. 8th root to the 5th power. And of course, you're writing down the things that you need to help jog your mind, but just if we go through a whole bunch of them, you're in better shape. It's this one. 6 is on the outside, so it stays on the outside. 3rd root squared. Okay. Minus stays a minus. This time the 4 is attached, so it's the 5th root of 4x and then to the 3rd power. So you can have this exponent inside or outside. It does the exact same thing, but the 4x here has to be under the radical and the 6 here has to be outside the radical. You've got to watch and see what those exponents apply to. This one, 1 over r to the 2/3, but then you've got to use your index and your exponent. This one, be careful. You're not distributing this 1/2 because there's a plus here. Okay, so this is really the square root of the whole entire unit, not individual ones, trying to point out the things that could be pitfalls for you. Now these, since they're in radical form, it's nice to be able to write them in non-radical form. So square root of 10 would be 10 to the 1/2 power, rational exponents. Z to the 6 over 6 is z to the 1st, which is just z. 3 to the 8/4, that reduces to squared, which turns into a 9. Makes it much easier than trying to multiply this out 8 times and then taking the 4th root to it. So our fraction exponents can, when you reduce them, make your work much easier for you. Okay, so I said that all the rules for exponents work even though you've got fractional exponents or rational exponents, and they do. So I've just got these here to remind you a little bit. If you have like bases, you add exponents when you multiply. This one's the reciprocal one. A negative power means that it's 1 over the positive. Or it can look like this. Okay, this is just another way of seeing this same thing. A over b to the negative m is b over a to the m. Same as this, it just means that reciprocals get rid of your negative exponents. Power to a power rule, multiply exponents. If you have things that are a product and you take them to a power, product to a power, the power has to apply to each one of those pieces. When you've got something in the form of a over b, that exponent applies to the numerator and the denominator. Now, here's the one where we'd like to think it through a little bit. If you have a fraction and you've got like bases, you can subtract the exponents. However, sometimes that could give you a negative exponent. So you can also think of it this way, is that if this number down here in the denominator is larger than this exponent in the numerator, then you can subtract them and automatically get yourself a positive exponent if you put that term wherever the bigger exponent is. So if this one's bigger, your result can go in the denominator and you'll have an automatic positive. If this one's bigger, subtract this way, and the answer goes right there. It's just a little trick. It saves you a step and having to deal with those negative exponents. So let's look at some examples. This one, like bases, means that you add your exponents. A half plus a fourth is 3/4. Okay, we have reviewed different times this year how to add fractions, but you've got your calculator. You can do it that way, but not a bad idea to be able to do the simple addition of fractions on your own. This one's going to be a subtracting one, but you need to think which one's bigger. 7/3 is bigger than 2/3, so I want to make that thing land in the denominator. And 7/3 minus 2/3 is nice, easy math. 1 over 5 to the 5/3, and this is just my little note. Since 7/3 is greater than 2/3, we make it land in the denominator, and we get our positive exponents there without having to deal with it. I don't have it in radical form. It doesn't have to be. Although some of you might remember, wait a minute, you have to rationalize a denominator. That's true, but that's a topic for a different day. All right, so we've got power to a power and the fact that you've got a product to a power. So we need to take this 4 and multiply it times both of those exponents. 4 times a half is 2. 4 times 2/3 is 8/3. Then we need to deal with the fact that we've got two y's, a numerator and a denominator y, and this is part of a product. So you need to subtract your exponents here. 8/3 though is bigger than 1, so that will take it to the numerator. And 8/3 minus 1 is 5/3. And so our simplified form looks like that. So be careful. You're always looking for where the greater exponent is when you've got the like bases to figure out where it belongs after you simplify. All right. These look more complicated. We need to rewrite it to have only positive exponents. We have to be careful here. This negative 2/3, yes, we could flip the whole thing over. I tend to prefer to try to bring this thing in first and then move things around. It just, to me, it feels more organized that way, so I don't have so much shuffling around to do. So I'm going to multiply this negative 2/3 times each one of these exponents. Okay, so when we multiply them times each one of the exponents, negative 8/3, 12/3, 4/3, and then negative 2/9. Yes, I know this can be reduced, and it should be. So you're going to reduce it and you're going to move things around so that you can get positive exponents. In order to make a negative and a positive for an exponent, just jump the fraction bar. Okay, so 12/3 I still kept. I didn't reduce it yet. 2/9 has to come up because it's a negative exponent comes positive to jump the fraction bar. 4/3 stays here. 8/3 to make it positive comes down. All right, this part's the part you might have to go back over a couple times. Now I can add my exponents, okay, in order to make that happen. And actually reducing wasn't the best plan here anyway, because what I need to do when I add exponents is have common denominators. So this would have to be a 9, so 36/9, and then 2 more 9ths is 38/9. You're adding the exponents, you're not multiplying them. And then here 4/3 and 8/3. 4 and 8 is 12/3. And now we can finally reduce what can be reduced. 38/9 cannot be reduced. X to the 4th is fully reduced, so we have that. All right, and then over here, what we have is this m to the 3/4, which can get distributed to both of these. Different than this. This one, this is getting multiplied in times all of these by power to a power rule. This is distributive property. So when we distribute, you're taking m to the 3/4 times each one of these. And when you do that, you add the exponents, and that's what's happened right here. M to the 3/4 times m to the 5/4, 3/4 plus 5/4. M, and then you add these exponents. This will give us 8/4, and the other one gives us 4/4, which we reduced 2 and 1. These are not like exponents, they're not like terms, so they can't go together. So reminding you, these fractions don't have to be scary, you just need some practice with them. And then finally, rational exponents can help you in simplifying. I know this one looks a little crazy, but we're going to get to that momentarily. 2/3, 1/4. Those are your exponents. Then add the exponents. Once you've added the exponents, you have your answer. If you tried to continue to deal with the roots, it would be really impossible to get this thing solved down. Here, once again, 3/2 is your exponent, 2/3 is your exponent. 3/2 is bigger than 2/3, so I can subtract those. And when I subtracted those, they would both be in terms of 1/6, because you do have to get common denominators. Don't forget that. So we had to have 9/6 minus 4/6, which would give you 5/6. And this is a 1/4 power, and this is a 1/2 power. So we have a 1/4 power to the 1/2 power. Multiply those exponents, power to a power rule, and you get an 1/8. So there you have it. Gone over fairly quickly, but we've hit all the rules having to deal with rational exponents, and reminded you that they apply regardless of whether it's fractions or integers. All right, that's it for the day, and I'll let you get working on your homework assignment that is due tomorrow. Tomorrow's just a video, and after you submit your homework that you're doing now, and then just a video tomorrow, and then you'll have a work day on Thursday for the assignment that goes with tomorrow's lesson. All right, God bless you, and have a great day.